on problem solving and reasoning. So for anyone who wanted to see the corrections or how to solve any problems from numbers 13 to 15, we're going to go ahead and get started with this. Number 13 says, Matt and Melissa want to build a carnival with both rides and an arcade. Below is a sketch of their plan. Write 2 expressions for finding the total area of how much space they will need. This here, if we think back to when we learned about the different expressions that can be written for area models that have a separation of a side length. We said that this was side A, side B, and side C. And we know that we can solve this in 2 ways. We can either just think of side length A times the sum of B and C, or we can think about it separately and say that we are going to multiply and solve for one box first, which would be finding the product of A times B, and then adding it with the product of A times C. So the first one helps us think about it and solve for it as if it were just one big rectangle. The second one kind of has us do 2 steps, but still takes us to the same answer because you find the area for the box that's with the side length B, and then you would find the area for the one with the side length of C. Then you would put your answers together and get the same answer, regardless of the 2 methods that you choose. So now seeing these formulas, I know that 30 yards is my side length A, 40 yards is my side length B, 60 yards is my side length C. And I can just plug these in. I know that I can do the side length of 30 times the sum of 40 yards plus 60 yards to get my answer. The other way of doing this is to get the area of the first box of the arcade, which is 30 times 40, and add that product with the product of the area of the rides, which is 30 times 60. And when you add these together, they would obviously give you the area of the entire space. So once again, we can see that our first expression here looks just like the expression A times B plus C. And our second expression here looks like the equation or the formula A times B plus A times C. If you were to solve for both, we would find that the product of each do give you 3,000 yards squared. And knowing this means that both expressions are written correctly. Number 14 says there are 2 lighthouses, one red and the other blue. The red lighthouse blinks every 12 seconds. The blue lighthouse blinks every 8 seconds. If they blink together right now, how many seconds will pass before they blink together again? Now, just thinking about our clues here, we know that because they blink every 12 seconds and the other blinks every 8, it would not make sense for them to blink together in any time less than that. This tells me that I'm going to use multiples, which tells me I'm going to use least common multiples. Okay? This also reminds me kind of like the Ferris wheel problem, the cicada problem, because it is asking how long will time pass before they blink together again. So in every situation that we've had dealing with time and something happening again, we've always done LCM. So my first step in doing this is to find the multiples of 8. And I'm going to label this so that way I know that this is the blue. The blue lighthouse is every 8 seconds. And that the red lighthouse is every 12 seconds. So the multiples for the blue lighthouse will be 8, 16, 24, 32, 40, 48. This does continue, but I'll pause there just to see if there's anyone that, any common multiple that we've run into so far. The multiples of 12 I know are 12, 24, 36, 48, and 60. Now with these that I did, I do see that the first one in common, they do have 2. I see that the first one is 24. I also see that there's 48 in common, but we have to keep in mind we are looking for the least common multiple. So I know in this case, the next time they will blink together again will be in 24 seconds. And I went ahead and I wrote this, my explanation as 24 seconds will pass before both lighthouses blink together again. Number 15 says, Carlos is packing treat bags at a party. Every bag has exactly the same treats in it, and there are no leftovers. Carlos has 96 granola bars and 64 small bags of popcorn balls. So in this problem, there's 2 steps. Step A, or question A, is asking for the greatest number of treat bags that Carlos can make. And it has us show our work. Now, thinking back to the question, I know that Carlos has 96 granola bars. I know that he has 64 small popcorn balls. So I know that he's not going to go out and buy any more. This tells me that multiples would not be the way to go. I know that we're going to have to break apart the 96 that he has and break apart the 64 that he has. So this tells me I'm going to be using GCF because I'm looking for factors. So I'll go ahead and I'll write this down, GCF, just to remind myself that's what I'm looking for. This means that I'm going to have to find the factors of 96 and the factors of 64. There are 2 ways we can do prime factorization, or we can list all the factors out. I'm going to go ahead and list all the factors out first for us, and then I'll skip ahead and explain the prime factorization method. First, I'm going to find the factors of 96, and then I'm going to find the factors of 64. I am back, and as you can see, I went ahead and I found all the factor pairs for 96 and the factor pairs for 64. I went ahead and I put them in a list, and I see that the greatest common factor, although I see that there are many common ones like 2, 4, 8, 16, 32, I see that of all of those, the greatest one is 32, which means that the greatest number of treat bags Carlos can make is 32. So I went ahead and I wrote this for us. And now I see that not only did I show my work, I found the common factors, and I see that 32 was the GCF. So my answer is the greatest number of treat bags Carlos can make is 32. If you felt more comfortable with doing prime factorization, you could go back to the video and look at the first video with question 8, where we found the GCF using prime factorization. So we did factor trees for 30 and 42, and we found that the GCF was 6. If you did that same procedure and followed those same steps for this problem, you would also get that the GCF is 32. So if you prefer doing that, just make sure that you look at that video a couple of times, and you can use that method to get 32, and your answer would still be the same, and you would say the greatest number of treat bags Carlos can make is 32. So I did go ahead and do the prime factorization, did factor trees for the numbers 96 and 64, and if you can see, regardless of the factor pairs that you use, you will end up with these prime factors in the factor trees. So the next step in this would be to write the prime factorization of 96, the prime factorization of 64, and then multiply the common ones. So here I see that there are 1, 2, 3, 4, 5 2s, so I'm going to write this as 2 times 2 times 2 times 2 times 2 times that 3 that's there. And for the number 64, I see that there are 1, 2, 3, 4, 5, 6 2s. 2 times 2 times 2 times 2 times 2 times 2. So these look like very similar factor strings, but I do see that they have 1, 2, 3, 4, 5 prime factors in common, which means I'm going to multiply these together and just do 2 times 2 times 2 times 2 times 2 to give me a final answer of 32. Keep in mind, you could also just see that there are 5 2's in common and solve for 2 to the 5th power, which does give you, again, 32. So this tells us that the greatest number of treat bags Carlos can make is 32. The nice part about the first method is that now that we know the greatest factor, the greatest common factor is 32, we can look to see what the factor pair was for 32 in each, and we would see that the factor pair for 96 was 3 times 32, and the factor pair for 64 was 2 and 32. Now, looking back at the question, I know that 96 was the number of granola bars, 64 was the small popcorn balls. So this tells me that this 96 is the granola bars. So I have to find the factor pair that went along with 96, which was 32 times 3, which tells me 3 granola bars will go in each treat bag. This also means that when we look at the 64, this is the popcorn balls. The factor pair here was 2 times 32, which means there are 32 bags with 2 popcorn balls in each. A good thing to do just to double check is to see if the number of granola bars match up with what was in the question. So if I look at my factor pair and I see I did 3 times 32, if I solve for this, I do see that I get 96, and I did have 96 granola bars to begin with. If I look at the popcorn balls, I know that 2 times 32 does give me 64, and when I look at the question, I see that I had 64 small popcorn balls to begin with. So I know that the answer of 3 granola bars and 2 popcorn balls do work for both. The challenge for the second part here says that John's parents just bought a new house. John is planning on different ways to arrange his bedroom. He drew out a model for what his room will look like below. The size of his new room is 12 by 14. The size of his bed is 7 times 5 feet. And the size of his nightstand is 2 by 3 feet. So the first step is to identify the information that's given. And I know that the important information is all going to be right here. Nightstand is 2 times 3. The bed is 7 times 5. And the room is 12 by 14. So taking a look at question A, it says if he places his bed and nightstand in the way that it is shown, what is the total area that remains and is available for the rest of his bedroom furniture? The best approach here is to start labeling the information that we know. So knowing that the side length of the room, or that the lengths are 12 by 14, I can label these this way. Okay. I also know that the bed is 7 by 5 feet. Last but not least, I know that the side length or the total lengths of the nightstand is 2 by 3 feet. And now I have all my information labeled. What I would do next is see what the total area of the bedroom is, and then find the areas of the bed and the nightstand and subtract that from the available space. When I do this, I can simply multiply and say that area for the bedroom is 12 times 14, which tells me that the bedroom is a total area of 168 square feet. So if this is the room, I now want to solve for the bed with the same steps. I know area is length times width. I know this is 5 times 7. And I also know that 5 times 7 is 35. Next, I'm going to solve for the nightstand. I'll label this N for nightstand. I know that the area is going to be 3 times 2, which tells me that the area of this is 6 square feet. This tells me that I can solve for the total used space, being the bed and the nightstand, 35 plus 6, and subtract that from the total, which was 168. When I do this here, I do get 41 for the total used space between the bed and the nightstand. So now I can just do 168 minus 41 to get an answer of 127 square feet. Part B simply asks, would the space available change if he arranges the bed and the nightstand differently? Why or why not? This is fairly simple. The area of the bed is not going to change. The area of the nightstand is not going to change. And the size of the room will not change. So even if he were to move it to the opposite side of the room, if he were to separate his nightstand and put it elsewhere, nothing will change with those areas. The same amount of used space will be 35 square feet and the 6 square feet from each of the pieces of furniture, which means you have 41 square feet that's being used out of the 168 that was originally available, which means the final the final amount of area available is 127 square feet. I wrote my expression as no, the area of the room, bed, and nightstand will remain the same, so the available space will not change either. So this concludes the review for the Primetime Unit 1 test. Once again, whether you're looking at this just to kind of see where you went wrong, it would be good to review and kind of have as a guide to use, just to know what you did wrong. If you're using this to study for a retake, make sure that you look through any questions that you got wrong, watch it a few times, look back to your notes, look back at any slides, and try to prepare yourself best for that retake. Good luck.